All right, today we're going to talk about absolute value functions and transformations and what they are. We're going to look at graphing absolute value functions, vertex of an absolute value function, because it's kind of a goofy graph. Transformations, translations, reflections. Um, we'll go ahead and get started here. Absolute value function. Let's just go through the basic graph. I want to t-table this so you can see exactly why this happens. Okay, in a t-table, we start plugging in numbers. Okay, well, let's plug in 0. And remember, f of x is just treated as y. So basically, y equals the absolute value of x. Well, if I plug in 0 for x, the absolute value of 0 is 0. So I'm at the point 0, 0. Okay, now if I plug in 1 for x, the absolute value of 1 is 1. So now I'm at the point 1, 1. Let's plug in 7. The absolute value of 7 is 7. So I'm at 7, 7. Okay, so I have something going like this. Now here's where it gets tricky. Let's put in, oh, I didn't put my other 7 over there. Let's start putting in negative numbers. Let's put in negative 1. What is the absolute value of negative 1? It is positive 1. Positive 1. Okay, and the absolute value of negative 3 is positive 3. So that means we're at negative 3, positive 3. And so what's going to happen here is the graph is going to look like this. It's going to be a V. And this should make sense because absolute values are never negative. So we should have nothing below here, below 0, because absolute values are negative. So that's why we end up with a V-shaped graph. Okay, well, now that we kind of know what it looks like, let's get into some goofy things. The vertex, the highest or lowest point of a graph. In that last one, my vertex was 0, 0. So what happens if I had y equals the absolute value of x plus 3? What's going to happen? Well, let's t-table and see what happens. X, y. Okay, well, let's plug in 0. Well, 0 plus 3 is 3. That's 3. So 0, don't be confused here. 0, 3. Okay. Let's plug in 3. Well, 3 plus 3 is 6. Absolute value of 6 is 6. So 3, 6. Okay. Let's plug in negative 3. Well, negative 3 plus 3 is 0. Absolute value of 0 is 0. So negative 3, 0. Okay. Let's plug in negative 6. Well, negative 6 plus 3 is negative 3. The absolute value of negative 3 is positive 3. So that's negative 6, positive 3. Where's my vertex? My vertex in this case is right here at negative 3, 0. Here's the trick. Here's the trick. We have a formula that says, or form, y equals a times the absolute value of x minus h plus k. I hope that looks somewhat familiar. Looks a lot like point slope, doesn't it? Okay, but here's the nice thing. HK is the vertex. HK is the vertex. So if I look at this, this is plus 3, so that's going to be a negative 3, and there's nothing out here, so it's 0, negative 3, 0. There's my vertex. This is why I want you to get used to point slope in this form, because it helps with absolute values. It's going to help with quadratics. It's going to help with conic sections. Good stuff. Good stuff. HK is your vertex. Okay? All right, let's move on here. Transformation changes the size, shape, position, or orientation. Okay? Now I'm getting all of this from page 124. 124. Okay, so all these things have a bearing on things. X minus h plus k. All right. A transformation changes. I can change the position of this graph by changing where my vertex is, right? Changing hk. I can change the shape by changing this because a is going to end up being your slope. Okay? So real quick, if I had y equals 2 times the absolute value of x. Well, now my slope is 2, so now it's up 2 over 1 on both sides. So I'm going to have a steeper, narrower v. Okay? So basically the transformations, in a nutshell, are just changing the shape of the graph, just using this formula. Okay? Orientation, same kind of idea. Reflection. Okay, and we'll get there. Reflection. Translation. A shift in the graph. There's no change in size. So in this case, y equals, we'll just do this, 2 times the absolute value of x minus 3 plus 2. Well, first thing I do is I'm going to find my vertex. Oops, I don't need this absolute value sign here. 3, 2. My vertex is at 3, 2. Okay? The slope from here is positive 2, so from there I go up 2 over 1, up 2 over 1, and I do it the same way the other way, because it's an absolute value. So my graph looks something like that. Okay? A shift. I shifted the vertex from 0, 0 to 3, 2. Okay? A reflection. To do a symmetric flip of a graph, all you have to do is make a negative. So if I had the same graph, y equals negative 2 times x minus 3 plus 2. Well, I still have the same vertex. I'm at 3, 2. Okay? But now my slope is negative 2. So now I go down 2 over 1. Down 2 over 1. Same thing on the other side. Okay? And my graph was a complete flip of the last one. Okay? Just by making this negative. If it's negative, it's got to open down. If it's positive, it's got to open up. Okay? Hopefully absolute values aren't too tricky for you. Hopefully we can get a handle on these and get some things done. If you have any questions, bring them to class, and we'll see you there.